Hey guys, this section is about the product rule. Now the product rule says that for a function y of x that can be written as the product of two other functions, f of x times g of x, so y of x is equal to the product of f of x and g of x, then as long as you know the derivative of f of x and g of x, it's actually really easy to find the derivative of y of x, because the product rule says that y prime of x is actually equal to f prime of x, it's a bad prime, f prime of x times g of x plus f of x times g prime of x. In other words, you differentiate one, leave the other alone, then you differentiate the other, leave the first one alone, multiply them together, and then add them. So that's what the product rule says. So if you forget that, just remember, differentiate one, leave the other alone, differentiate the other, leave the first one alone, and then add them together. That's a bad plus. Okay, so that's what the product rule says. We're going to do a quick proof of that. So there's a little trick in the middle where we subtract something and then add something and then add that same thing on again. But other than that, it's reasonably standard. So, to begin, notice that y prime of x is actually equal to the limit as h tends to 0 of y of x plus h minus y of x divided by h. And that's just the definition of the derivative. So that's y prime of x. And now, this is equal to the limit as h gets closer and closer to 0. Well, y of x plus h means we put x plus h in here, which means we put x plus h in here and x plus h in here. So y of x plus h is actually equal to f, wrong color, is actually equal to f of x plus h times g of x plus h. And y of x is still equal to f of x times g of x, so that's minus f of x times g of x, and we're still dividing the whole thing by h. So that's where we're at so far. Let's go to a new board. So, and now let's just write out where we were. So we're still equal to the limit as h gets closer and closer to 0 of f of x plus h minus, f of x plus h times g of x plus h. So that's y of x plus h minus y of x, which is f of x times g of x. And then we're dividing the whole thing by h. And now we're going to do a little trick, and here's where I have to write kind of small. So the trick goes like this. We're going to subtract something and then add that something back on again so as to make sure we're still equal. And then we're going to factorize out some convenient terms. So this is equal to the limit as h gets closer and closer to 0 of f of x plus h times g of x plus h minus, and we're going to subtract f of x times g of x plus h times g of x plus h, and then we're going to add that back on again, plus f of x times g of x plus h, and then we're going to minus f of x times g of x again. And so that's this one here. So all we did was we added this thing on, and then we subtracted that thing, and then we added it back on again so as to cancel that off, because we want these things to still be equal after we're done. Let me just close the door. Someone's banging in the background. It's annoying. Making a big banging sound, making it impossible to focus. Okay, so door is closed now. So this is equal to the limit as h tends to 0 of this huge thing where these two terms cancel out, so we're still equal to where we were, and then we're dividing this by h. We're dividing by h. Okay, so now we're going to factorize as promised, and we're going to factorize by observing that this term appears in both the first two parts. So we're going to pull that g of x plus h out to the front. So this is equal to the limit as h tends to 0 of g of x plus h. So drag g of x plus h out, and then we're going to have in brackets f of x plus h minus f of x, close brackets. I think those things are called parentheses, actually. This and this might just be called parentheses. Brackets is something else. I don't know. Anyway, don't worry. I'm just going to call them brackets. Hope it doesn't cause too many problems. So g of x plus h times f of x plus h minus f of x. And we're going to do the same thing over here. We're going to factor out this f of x term because that appears in both of those last two bits. So plus f of x times g of x plus h minus g of x, close bracket, and then this whole thing is divided by h still. Okay, things are looking really good. Things are looking really good. Well, now we're going to split this fraction up because actually, well, the limit, well, we'll do it in two steps then so as not to be confusing. This is equal to the limit as h gets closer and closer to 0 of g of x plus h times f of x plus h minus f of x. And that whole thing divided by h plus f of x times g of x plus h minus g of x, and then that whole thing divided by h, because, you know, if you've got a fraction a plus b, it's horrible, a plus b divided by c, that's equal to a divided by c plus b divided by c. That is all we've done here, because for all the values of h we're concerned with, we just have a regular fraction, because we're concerned with all the values of h that are non-zero, but getting closer and closer to 0. So that's kind of important. And now, something else to consider. For the function g of x to be differentiable, so before we can actually get a derivative of g of x, it must be the case that as h gets closer and closer to 0, g of x plus h gets closer and closer to g of x. We need that to be the case. So the function is actually not differentiable if it looks something like this, where this is the point x, and then this is the function g of x. Well, this is the function, this is the function g, and then g of x is actually up here. Then that's a problem, because as we get closer and closer towards x, the function doesn't actually get closer and closer towards g of x, and that makes this condition no longer true. So we can't have that situation if what we're going to do, if what we're doing will work. That situation is impossible. Hopefully that wasn't too confusing. So basically, yeah, if we're going to differentiate the function g at the point x, we need this thing to be true. We need it to be true that as h gets closer and closer to 0, g of x plus h gets closer and closer to g of x. Now, let me squeeze one more line in here. This is, well, what we've got is kind of a product here. Well, now first we have a sum, I guess, actually. So we can split this sum up. If this part of the sum is getting closer and closer to some number, and this part of the sum is getting closer and closer to some number as h gets closer and closer to 0, then the whole thing, both of those two things added together, is going to get closer and closer to whatever this thing gets closer and closer towards, plus whatever this thing gets closer and closer towards. So we can actually just rewrite this as the sum of two limits. We can rewrite this as the sum of two limits. That's what we'll do. So where we're at now, what we actually have is the limit as h gets closer and closer to 0 of g of x plus h times f of x plus h minus f of x divided by h plus the limit as h gets closer and closer to 0 of the other thing, f of x times g of x plus h minus g of x, and then that whole thing divided by h. Okay, so that's splitting up the sum of the two limits. So splitting up the limit of the sums is equal to the sum of the limits, basically, is what that rule is saying. So if you've got limits of a plus b, and a and b are getting closer and closer towards something, then that's equal to the limit of a plus the limit of b. That's what we were using there, if that was confusing. Okay, and now we need to use basically the limit of the products is equal to the product of the limits. And so we've got a product here because we've got g of x plus h times this thing. We've got g of x plus h times this thing. And we're taking the limit as h gets closer and closer to 0 of this thing times this thing. Now, well, if g of x plus h is getting closer and closer towards some number, and if this thing is getting closer and closer towards some number as h gets closer and closer to 0, then, well, the limits of that product must get closer and closer to the product of whatever those two things get closer and closer towards individually. In other words, limit of a times b must be equal to the limit of a times the limit of b. If a and b are both getting closer and closer towards something each, then the limit of that product must be equal to whatever this thing is getting closer and closer towards times whatever this thing's getting closer and closer towards. So that's what we're going to use now. So we're going to split up these limits again. So this is equal to the limit as h gets closer and closer to 0 of g of x plus h times the limit as h gets closer and closer to 0 of f of x plus h minus f of x divided by h. So we're up to here so far. Plus the limit as h gets closer and closer to 0 of f of x times the limit as h gets closer and closer to 0 of g of x plus h minus g of x divided by h. So that's where we're at so far. We just split up those two products, that limit of the product, into the product of those limits using the rule we just wrote down before. Okay, well now we're nearly done, because actually by the assumption we made before that g can actually be differentiated, the limit as h goes to 0 of g of x plus h is actually just equal to g of x, because this thing gets closer and closer towards g of x as h gets closer and closer to 0. Now this thing here, by pure definition, is just equal to f prime of x, by the definition of the derivative. Plus, now, limit as h tends to 0 of f of x. Well, f of x has nothing to do with h. Actually, f of x is just a fixed number as far as we're concerned, so that's just going to stay as f of x. As h gets closer and closer to 0, f of x remains at f of x, and therefore it gets closer and closer to f of x. So that's what's going on there. And then finally, again, by definition, the thing in this last circle is just equal to g prime of x. So yeah, we're done. That's what we set out to prove. We started out with y prime of x. That equals that. Equals. And then we're done. So that's what we set out to prove. So the derivative of y of x, where y of x was equal to f of x times g of x, turns out that when you differentiate that thing, it's equal to g of x times f prime of x plus f of x times g prime of x. Okay, thanks very much for watching. Don't forget to check out the notes on this section. Thanks, bye.